Welcome to this month's edition of the Transylvania Lectures series. My name is Péter Ákos. I am a student at the Matthias Corvinus Collegium University program from Kolozsvár, Cluj-Napoca. This event aims to create a platform for the local public where we invite renowned academics from all around the world with whom we can discuss topics relevant and interesting, not just for our Transylvanian society, but also for the larger intellectual sphere. It is my honor to present our dear guests and today's topic. Thank you for accepting our invitation. Professor Dr. Torbjørn Netland is a full professor and head of chair of production and operations management at ETH, the Federal Institute of Technology from Zurich, Switzerland. He is a member of the World Economic Forum, the Global Future Council on Advanced Manufacturing and Value Chains, and a fellow of the European Academy for Industrial Management. His research on achieving and sustaining manufacturing excellence appears in leading scientific journals, and he is co-author of the 800-page textbook about manufacturing. Torbjørn is also a co-founder of Aton AI, which is a startup offering state-of-the-art AI solutions for quality management. The discussion will be moderated by Dr. Levente Szász, Vice Dean and full professor at the Bábes-Bolyai University, Faculty of Economics and Business Administration, Department of Economics and Business Administration in Hungarian language. At this Transylvania Lectures event, Dr. Professor Torbjørn Netland will showcase a variety of research projects conducted in his group in cooperation with industry leaders. By showing examples ranging from explainable AI in Siemens to drones in IKEA, the speaker highlights the great potential of new technologies to innovate and improve performance in manufacturing. Let the lecture begin. Gentlemen, the floor is yours.
Thank you very much. Good afternoon, everybody. I'm really happy to see so many people here. And first of all, I would like to start with thanking Torbjørn Netland for accepting our invitation. I have met Torbjørn at many international conferences, summer school, other professional events, and I and also my colleagues, we also always admired his work. So it was this idea that led us to inviting him and share some of his ideas, some of his research with the local community. As an introduction, how I would like to place today's presentation and also discussion, and at the end there's an opportunity to add your comments, put your questions, so we can make a discussion at the end of this event. But again, I would like to start with the keyword digitalization or digital transformation, because this is, how would I say, the mega trend, or this is the current which we are currently living in terms of also business world. However, behind these buzzwords, what we see also in our research, and I'm pretty sure Torbjørn will also share a couple of examples and experiences, it's not without any problems. And what we see in our research, for example, is that there's very rare that we can see a full digital transformation of a business. We were more likely to observe were that we have islands or individual projects where a new digital technology like AI or drones is introduced in the business, that full digital transformation, that revolution that is promised here, or in the fourth industrial revolution, how we coined it in one of our papers is that it's more likely to see an evolution instead of a revolution. So for that fundamental change to happen, it's still, I think we're still at the beginning. And it's good at the beginning to see a couple of good examples, so that's why we are here today. But however, let me point out one other important idea besides this being at the start of digital transformation. That's how I see, or that's how our research team sees this fourth industrial revolution. The other idea is more connected to Romania and the eastern part of Europe. And let me just share one single statistics concerning this digitalization trend. If we look at the ESI index of Eurostat, the Digital Economy and Society Index, So basically they measure how do different countries stand currently in terms of digitalization. They have a business digitalization pillar, so they measure how businesses are in front or how advanced they are in digitalization. And what we see again, so long story short, Romania is at the last position in the EU, so it's the 27th position, which is one thing. Okay, that happened to other indicators as well, and we could catch up quite beautifully in the last couple of years if you look at GDP per capita or other economic indicators. But there's a pretty worrisome indicator. We also calculated how much we improved in terms of this digitalization of businesses, and unfortunately the pace of growth is also the last one in the EU. So again, summarizing, we're not just on the last position in the EU, but we are also the slowest growing country in terms of business digitalization. That means the gap is not closing, but it's widening. And that's why we also applied for an EU-funded research project, which we just won 3 months ago, where we focus on helping, or at least, discovering the real challenges and trying to come up with solutions in terms of business digitalization. And again, probably the answer lies in these individual projects, case studies, use cases, and we have to look at this problem in more detail, in more on a more fine-grained level, and not just the very umbrella view or very bird's-eye view on digitalization. So that's why the idea was, and when discussing with Torbjørn on email, was that, okay, what would be probably the most useful for us today is to see a couple of good examples, successful use cases of digital technologies. And Torbjørn promised us drones and AI, which I think, again, are at the forefront of this digital trend. So I think this is how we can connect to Torbjørn's presentation. So Torbjørn, I think I can give now the floor to you, and we are really interested to see what these use cases and what the lessons of these use cases could be to the local community.
Thank you, Levente, and thank you everybody who showed up here today. My name is Torbjørn Netland, has been introduced. Professor of Production Operations Management in Zurich in Switzerland. And you had quite a scary statistic there, which may fit the whole Transylvania story, at least from abroad. But I want to start with a more maybe optimistic tone for me. It's my first day in Transylvania and Romania, and it's been absolutely wonderful. So it shows that there's, of course, lots of potential as well for this country and region to impress outsiders and do great stuff. May I stand up, or are you ruining your filming setup here? Because I'd love to. No, not talk. Oh, come on! I'm gonna stand up a little bit. You just move the camera, okay? I need to see you properly. And the camera people will have to work a little bit harder. It's okay. Okay, so I'm going to talk about when drones and AI enter the factory, and there's not going to be many drones in factories in Romania after this talk. Just to be clear about it. Actually, it's quite often not even needed. So the key is to find exactly what technology can solve key problems that you have. And that's what I want to showcase, because drones did solve one problem in a company. And without further ado, I'd just like to dive straight into the use cases, as Levente called them, and I also call them. We focus on use cases more than digital transformation, which is a big word and can mean many things. Have you been at IKEA? You have IKEA here in Cluj? No? Oh, you have to drive many hours to get. Not yet. It will come, I'm sure. They are expanding. Imagine you check online, you want to buy a Billy bookshelf or a luck table or something like this, and it says it has it. You travel, I don't know how many hours. How many hours? 6 hours! You come to IKEA, and that table or closet that you saw online they said they have is not there. Okay, then you get quite frustrated. Inventory accuracy is an exceptionally important metric in retail. Also in manufacturing if you have a lot of parts and goods, but more so in retail, because the only thing you do is to sell things that you have on shelf. If you don't know exactly what you have, where you have it, you have a problem. And most companies that move, you know, they move thousands of units of goods every day. Company like IKEA, thousands of furniture go through their warehouses. And the same on online retail in these places. You can have a good inventory accuracy, but if it's say 99%, it means that every 100th customer, given that they only buy one thing, will not get what they wanted to have, or what you told them that you have. And this is very dangerous for a company in that position. You lose, of course, reputation. That person talked to another person, don't order by them, they never have what they need, and so on and so on. In addition, you have to manage to try to find, where did these goods go? The things that you said you had in the warehouse system, where are they in the warehouse? Okay, so inventory accuracy is actually a KPI, key performance indicators, that the retail industries compete on. The guys with the best inventory accuracy has a competitive advantage. Okay. For years, people have thought, can we use drones to count inventory or take images of what we have and update? This is since 2016, roughly. And many attempts, most of them failed. Very often as well because, you know, instead of climbing a ladder to count, which usually you would do in a cycle counting type of procedure, you have a person flying a drone. You just basically replace the person on the ladder with the person behind the drone. It's just as costly and much more difficult. But then there's been a breakthrough in drone technology that makes this technology today fully autonomous if you build it ground up. We have been studying this since 2016 in many different industries, but it was first around 2020 that we got to work with IKEA. And look what IKEA is doing today. Now I take you with me to Switzerland. Outside Zurich there's a warehouse in Spreitenbach. It's one of the oldest warehouses actually of IKEA outside Sweden. And if you go there, you can almost see this. It's behind an area where you can't see it, but still you can go in. And when the managers of this facility turn off the light in the evening to go home to their family, these small drones awakes from their sleep. And they go and they take pictures and scan every place that the warehouse management system tells them there has been a movement of a pallet that day. Every single day. They go like this. There are 8 drones in that warehouse. This, of course, to do this, they piloted it, they worked with the company that offered the drones, and they were able to implement it. You see, this is exactly how it works. And then they go back to sleep in the beehive. When they are back in that little box, they charge, right? And they transfer the data automatically to the warehouse management system. So, while the managers have been sleeping, they wake up, they come to the warehouse, they turn the light on, turn the warehouse management system on, 100% inventory accuracy. They know exactly what is where. And that's unheard of actually in this type of industry before these drones. The thing that makes it competitive is that the drones are fully autonomous. They work 100% of the time. This was in Switzerland. Today, IKEA has scaled this use case to 16 warehouses and they are still rolling it out. More than 100 drones fly in IKEA. I think it's the only retailer that is really doing this at scale. There are also some logistics companies that do it. Pretty cool technology, huh? But for most companies, it doesn't make sense. It does for IKEA. You can read more about this. We will distribute the slide set. So if you want to read more about the IKEA case, there are articles we've written about it, and you will get access to this. That's IKEA. Let's take a completely different case. Siemens. You heard about Siemens. Everybody heard about Siemens. Huge company and really professional as well. People talk about the 4th industrial revolution. They talk about digital transformation. And what are the case company? Siemens. So where Toyota is the case company often for lean, Siemens has become one of the stars for digital transformation. But guess what? Siemens have the same problems as every other companies. They do the same type of mistakes, even how professional they are. Let's take an example. This is a quality inspection task. And now I'm going to take you to a factory, Siemens factory that builds fire alarm system, industrial grade. I hope there's some here. Yeah, okay. Wonderful. If it's Siemens, very good. We are safe. So in this is a picture of the factory. I hope you can see it from back there as well. It's a clean factory. There are lots of manual work, but also a lot of machinery. And each of these fire alarm systems have a printed circuit board. One of these green things, PCB on them. And because they are not so high volume, because they are industrial grade, and they are developing them fast, it's still manual labor that puts these things together. Some machines, some manual labor. Guess what happened when people put things together? Thousands of parts. They make mistakes. Okay, it happens. 1 out of 1,000 times they make a mistake. 1 out of 500 another day. Do we want to have fire alarm systems with mistakes in them? No, it's pretty obvious. You can imagine how expensive it is if a house burns down and Siemens is to blame because their fire alarm system didn't work. So what they do is inspection. For 50 years we have talked about in the lean world to get rid of inspection because it's a non-value add. Build quality into the process. Build quality into product design. That's all good. Okay, we should do. The fact is still, we never get to 100% quality accuracy. Very, very hard. So companies still inspect, and they do it in all type of industries. In fact, in electronics industry, almost every second step is an inspection or testing step. So it's a big thing. How many of you have inspected products on the shop floor of a company? 1 person? 2? Okay. Very good. Now we're going to have an inspection task. You're going to have an advantage. Okay? So in this factory, each of these printed circuit boards have to be inspected. It's a small screen, so you better have good eyes if you're sitting at the back, okay? But let's see. Here is a fault-free printed circuit board, real one from the factory. I'm going to show you a picture here, and you're going to tell me, you're going to inspect it. Is it defect-free or defective? In this factory, you would usually have 5 seconds to make that decision, because there's another thing. Are you ready? Is this defective or defect? Or fault-free? You have 5 seconds. Anyone? Is it okay? Should we send it to the customer?
No, it's defective.
Look, the inspector has seen it. Wonderful. Have you seen it? Why?
Because that small thing is red on the side.
Operator forgot to assemble a little cap, which can happen. This is a real error that happened in the factory, and you got it. You have 5 seconds. Not all of you. Just don't. No, not all of you. Some of you. And you can also see the difference in human skills on this type of task. Here's another one. This is going to be a little bit harder, maybe. This is a typical fault-free printed circuit board, and you have 5 seconds to inspect this one. Is it defective or fault-free? Some people are citing. Look, when you are working on the shop floor doing inspection, as some of you have, it's hard work, mentally demanding. And you know what's the most important thing about the task? You have to make a decision. Yes or no. If you work in management, well, let's discuss tomorrow. Oh, we can do. On the shop floor, you make a decision every 5th second. And that can potentially burn down a house. Of course, they have redundancy system. So now we have got like 30 seconds. What do you say? Defective?
Defective.
Defective? Yeah. Why? Okay, let's. Why? Look, he's there. Levente is like there. He sees nothing. So anybody here said defective?
The middle point, the black point in the middle.
Black?
Top.
Which? Here?
Yeah. No. Yes,
This?
that's
This black point?
Yeah.
A little color? It's just because of the lightning when you took the photo. So no. Anybody else? No, you got silent? Oh, come on, if you saw it. You know you did the right decision, but for the wrong reason. This is defective as well. It also happened. You see this one? Is one, you know, it's a little bit too broad. Somebody kitted the wrong part. Happened. Logistics kitted the wrong part. Happens. Okay? It's too long. Dangerous. Can burn down the house. And you said nothing. This is a very hard task. Now we can use technology to make this task simpler. This is a real task happening in one of the leading companies. So what we did is that we built an explainable AI system. It's very simple to explain. You see a printed circuit board there. We have a camera that costs $400. You put it on there, you take a picture, the AI reads it and green suggests it's okay. Now you can see we purposefully mount the thing wrong, and then the camera reads it, and the AI suggests that there's something wrong with this one. And not only does it suggest it wrong, it uses explainable AI, an explanation for why it thinks it's wrong, which is the heat map. The heat map points you to the area where the explainable AI system thinks the system is wrong. Can you imagine doing the task you just did with the help of this system? Would you be able to find 2 errors? Of course you would. And this is fantastic. I mean, this is a simple, nowadays perhaps, AI system, of course advanced algorithms. We implemented it in the Siemens factory. Siemens have scaled it to the US, to Germany, and are scaling it in other factories. Guess what? It works. And instead of automating and replacing the human, it's just helping the human doing the job. Because you still need a human there. If there's an error, you need to find the fault. You need to decide what to do with it, repair or scrap. Many good reasons to keep human in the loop. Okay, we did some research on this as well. So we designed an online experiment, and we ran it with many people online. We also run the same experiment as you basically just did in the factory. I'm going to go a little bit quickly over this. This is the research design that we did. Some people get just the tips of an AI whether or not the product is likely wrong, and another group gets the explainable AI that you just saw. Here's the results. These are online people from an online crowdsourced platform. Just basically pay online and people do the task on their computer. They don't know nothing about inspection, like most of you. Okay, there are 2 people in here that know more about inspection than the rest. This orange line is the AI performance. All online participants were outperformed by the AI. Maybe bad news for human being. AI is better than a human from the street, so to say, to do a task like this. This is the bad news, but there are good news. When we run this in the factory with experienced inspectors, if the inspector only got an AI system that said, yeah, maybe it's wrong, maybe not, I think it's wrong, then the human being, the expert, overrule the AI to an extent where they do worse. They actually say, the AI said it's probably a defective, and then the human says, I can't see it, it's probably okay. So they overrule and do worse. But if we give them explainable AI, the heat map that you saw, an expert inspector with the help of AI outperforms AI alone. Wow, AI plus human outperforms AI alone. Good news for humans and good story. This, by the way, is a very lean way of thinking as well, but you help the operator succeed in their job. Okay. And you can read more about this. And let's take the next case. Now I've showed the drones. That's quite science fiction. And then an explainable AI. Now we're going to talk about Stanley Black & Decker, American company. I think you've heard about them. They make tools in industrial grade and also for normal hobby users. They have a problem called machine changeover. Not maybe everybody know what a machine changeover is, but if you work in industry and you're here, you know what that is. That sometimes you need to change the whole machine to produce a new product or another variant of the product. That is can be very kind of complicated replacement of tools and things inside the machine. And very often it takes hours. This is the case for Stanley Black & Decker. And they have factories all over the world. And all these factories have machines that needs changeover. All companies usually have that, right? Here's the problem. When you do a changeover on a machine, you need an expert to supervise it. It's a thing that takes an hour. You cannot afford to make mistakes. So you have an expert that supervises it and said, good. In addition to the operator actually doing the job. Problem, these experts are scarce. You don't have experts hanging around the factory just waiting for another changeover. So you may have few of them. And few have the skills to actually change over these very special machines. Now, Stanley Black & Decker spread their factories all over the world. So they need to travel to many places. Takes a lot of time. Oh, COVID-19, if you remember. Nobody could travel. How do you do expert supervision if you don't have one in the factory? Not just that. I heard that now there's some volcanic activity on Iceland again. Anybody remember? Icelandic volcano. These things happen, so it's hard. Geopolitical conflicts, as you are well aware of. And then the thing that then happens is that the machines often stand idle, waiting for an expert to come and supervise the changeover. Big problem. Can we solve this? Maybe we can use remote. Okay, somebody remotely through IT looks at the changeover. Okay, that doesn't sound so fantastic because we know we can just use Zoom, Teams. Problem that doesn't work so well for changeovers. With very complicated detail inside the machine. You go with the computer on the shop floor, doesn't really work. Hard to hear, difficult. Some companies came up with some more fancy things with camera and stuff. You can be on the shop floor. Still, it has the two-dimensional limitations. You probably heard about virtual reality. That's very nice. In virtual reality, you can meet with different people around the world at the same time, in real time. The problem? It's not real life, right? It's not the real factory. You can only build digital copies of the factory, so it's not solving the problem. And finally, live streaming activities. You can live stream sports event to thousands of people, but then you can't talk with a goalie and the thing. So our idea is, let's combine all these different technologies in a new technology, and then see if we can do online, remote, real-time changeovers. So engineers at my team started to build an artifact, as we call it. Here you can see a helm, and it's a 360 camera. And they have phones on them that send this video stream to a live stream platform. In addition, we have the remote people in VR headsets. With this, they can actually meet real-time up there with the 360 real-life. This is quite difficult to, but let's see, we worked on it. Here's a student at ETH, he's making the helm and a few of these things, developing that stuff. And here is a picture of the real changeover. So this is a machine at Stanley Black & Decker in a factory in Germany. And you can see here a person who's trying to do a changeover. Okay. We found, this is back in 2021, one company in the world that was able to provide us the technical solution we needed. It was a startup from California. Of course, California. Avatur. And they were able to provide maximum 5 people at the same time in the same space, real time, with 360 video transfer. You can imagine how data computing heavy it is, with 360-degree video streamed real time at different headsets. Okay, it's not, but, and then we tried to do this in a 3-hour machine changeover. And this is me in my office in Zurich taking my headset on and see if we can make this work. Let's see. Okay, so it works. Let me show you what I'm looking at here. This is a little bit theoretical, a little bit okay, extra. Yeah. So here is first, we have 2 different systems. Here's with the helm. You saw that 360 camera on the helm. It means somebody in the factory have that helm, and I'm there in my office. And you can, this person is moving, and I'm moving. I got a little bit seasick, see? But it worked. And here you can see me basically logging into the system. Log in, boom, 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 and boom, I'm there. This is real time. You know, I move my head and I can see around. I can see the tool coming in here. You see my arms. And I turn around, I can turn around. 360, I'm in the factory. And look here, it's Tucker. There's another person on the same call, an avatar who's called Tucker, and he's right next to me. So this is real-time live streaming, which is pretty cool. Let me see, I think he will stop soon. And here you can see the tool is coming, so we could watch this. Now you can see Tucker needs to watch his head a little bit, but since it's virtual, it doesn't change so much. Here on the other side is with the suction cup. And now we basically, inside the machine, we put the 360 camera. So now it's only my movement, makes it much better. And I can decide where to look. And I'm inside the machine, which is very hard to do if you're even on there as a person. You know, normally the expert would stand behind him and look over the shoulder. I can actually look straight at his movements. You could do a few of these things with 2D as well, but then you could not move. And now you will soon see the big advantage of this live stream. So I think he's moving around a little bit. He goes now around the machine to do another task on the other side of the machine, which is often normal when you do changeovers. And the nice thing is I can just turn my head, and here you even see the suction cup. Okay. So this is I think is something that's going to come more and more. This is not on the market yet. I mean, you can find some solutions, but maybe this is what we talk about metaverse in a little bit. I mean, we're going to meet virtually, but in real life at the same time. Maybe it's coming. Pretty cool thing. Then you can, of course, read more about this as well. Here's the last case I'd like to give you. How are we on time, Levent? Is okay?
Yeah, sure.
Have you heard about Lindt and Spröngli? You know what they make?
Chocolate. Yes.
Yeah, they make chocolate. These are Linder balls or Lindorkugel, and they are world famous, and you can buy them for far too much money everywhere in the world. They earn lots of money on this, which is good for them. It's good chocolate, and we work a little bit with Lindt as well. Okay, this is not a lecture on chocolate production, but it's okay to understand how complex it actually is. It's not just melt some cocoa liquor in a bowl and then you make some chocolate bars. It's very complicated. Why? Because the coffee bean, or in this case, of course, cocoa beans, have different grade. They come from different parts of the world. They can have different, traits and things like this. Maybe they are sun drying is a little bit affecting them in different ways. Then you make cocoa liquor out of this, and you have to do a lot of different steps to get rid of other kind of elements. Lindt, by the way, does all of this themselves. Most chocolate producers buy cocoa liquor from somebody else. So Lindt try to stay in control of everything. Then you go into something called mixing and conching, and here temperature is extremely important. You need to control the temperature, otherwise you destroy the chocolate. And the same as the temperature, you need to do something like conching. This is actually the invention of Lindt, where you move the chocolate in a particular way so it gets that smoothness that you need for chocolate to taste good. Okay, then you fill nuts and whatever you'd like to have with it, and you mold it into packages that you can also, of course, cut it, but usually it's molded. What's the problem for Lindt? Well, their problem seems maybe on the surface not so important, because they are very, very, very good in producing chocolate. You have to be. So yield, which we usually call the output to input, I mean, how much do you lose? Let me draw that here. Some of this is thrown away because it didn't work, or the machine stopped and the chocolate, got hard or something like this. You have to scrap a few of these things. Some of it you can rework. Also expensive, because you take production capacity, you need to deal with it again. Anyway, more than 99% and far above that actually is very good chocolate from Lindt. So why is this a big deal? Because for the Linder, these balls, they make on one line roughly 40 million a month. 1 million balls a day on one line. They have 14 lines. If you take the waste from one line, just one line, I can feed every people in Cluj 10 free Linder balls every year. Okay, that's quite a bit. That's lots of tons of chocolate. So it's very small percentage-wise, but it amounts up to huge volumes and very expensive to lose all these things. How can you improve it? And now it becomes a little bit complex. You can imagine they have worked on this for years and years and years, and they've got a very high yield. How can you get it even better when you've tried everything that you basically have been taught at school. First, what they try to do, and everybody should, is something called lean production. Maybe the audience has heard about that. It's Toyota's philosophy of production. Very good and smart tricks and tips to reduce waste in production. Many global companies have a system for this. In Lint, they have something called Lean Production Way, and they work with the Japanese Institute of Plant Maintenance to try to get better and better and better. Even if you do this, because they have, you will have some waste. So what else can we do? We have to try to figure out what's the root cause of yield loss. And these lean tools, they gave us simple rules like 5Y and a few things. It's not enough to come to the real root cause often. Why? Because chocolate production is complex and non-linear. Let me look at this. Here you can see these balls are being molded, and the temperature of the chocolate affects, for example, how much they stick to the crate here. Of course, you can imagine. These things are knocked out, and here you can see already waste. Did you see 3 or 4 balls? Do you see the woman who worked there? She tried to fix it, and then basically they make millions of this. It's very complex, because all these different things that happen in the different settings can affect the outcome. How can we do it? Okay, digital transformation. We try to do that. Basically, what does that mean? Collect as many sensor data and machine data as you can from the production system. This is just data. And then you try to replicate the process in a model. And that model can be very simple or very advanced. The key point here is to find the processes that, of course, they know because it's from here, but the data that represents things that can go wrong in the different processes, and then try to regress it, as it is called, on yield. For a human being to go through this with all the non-linearities involved is impossible, because it can be, if the temperature here is 0.5 Celsius degrees higher, it affects another process that again affects the yield. Very hard to see. Computers, excellent with these kind of things. If they just have enough data, they'll figure it out. So that's basically what we did here. We build a system that looks at all this data, and historically in the past tried to look at the parameters that were out of range or out of scope when we had yield loss. Okay, it's a little bit more complicated case. And Lint is now using this tool. If you love theory and academic things, you can study this as well. Actually, if you go back to the 70s and 80s, there were quality gurus. Maybe some of you have heard about Taguchi, Deming. It was a whole area of quality. And they had a lot of good theories, and we just use their theories today. Basically, what we try to do, this is the process quality, and this is the distribution of the product, okay, on quality loss. We just try to take this quality loss and make it narrower. If we do, we will automatically push this curve to the right. This is insights from some research. And that's basically what we try to do here. The trick, of course, is to get the data from the system, and maybe we can talk about this when we enter the discussion afterwards. You can read about this as well, where we studied this in the semiconductor setting, basically the same thing. Okay, so I'd like to round up, because now I've talked about 4 cases, and they are very different. So what should we do? I mean, just do a lot of cases? Okay. The fact is that managers today are a little bit overwhelmed by the opportunities in technology. AI, for example, alone. There's thousands of things you can do. Now, if you add the blockchain, virtual reality, augmented reality, drones, most managers, actually most of us will say, okay, I don't know what you're talking about anymore because I can't follow. And this is true. So managers are lost. So what do the companies do that actually are able to move ahead and not just give up because of the possibilities? That's what we actually look at in the World Economic Forum Lighthouse project. This is something that the World Economic Forum started together with McKinsey in 2016. And by now they have awarded 132 lighthouses. Are any of them in Romania? Do you see? Maybe you have.
Yeah, one.
Yeah, you know them as well, maybe. Okay, so these are 132 companies that have been awarded for their excellence in Industry 4.0 or digital transformation. What do they do? What do they do differently? That's interesting to know. By the way, they are the usual suspects. Bosch, Siemens, Haier, lots of Chinese companies actually, Foxconn from Taiwan and so on and so on, Johnson & Johnson. They all start with a strategy. So they do sit together and think about how can we use technology to improve our production processes. And as part of that, they build on their lean programs that they've always had, their production systems. This is what observations of what we see. And here's an interesting thing, Levente, because you started to say that maybe it's better to pursue good use cases than just try to do digital transformation. And I think these companies agree. What they usually have is a portfolio approach with 20 to 30 use cases in the factories. And the thing that differentiates them from the rest is that they scale them across the factory. Those that work are scaled. And those that don't work are stopped. And so it's not so much harder than that in the sense you need to just experiment and learn or work with students, have a master thesis, test it out, does it work? Fine, use it. If it doesn't work, fine, let's come back to it in 3 years. So that's fast experimentation. And then all these companies do say that they have very, very fantastic benefits of the digital transformation. But as a researcher, these guys don't report their cost. So I don't know actually to what extent it's helping them, but at least they're doing something interesting. Actually, that's what I wanted to say. 4 cases and then we can discuss. What do you think, Levente?
Yeah, does it work? Yeah, thank you very much, Torbjørn. I think fascinating examples and use cases, even looking at some that are not yet on the market and nothing similar on the market. I think even for me, those are really surprising, although I read some of the papers you've already shown. So I think it's time for discussions. I would have a lot of questions, but I can discuss with Torbjørn during the dinner as well. So I don't want to rob your time. So if you have any questions, comments concerning what you have seen, heard, listened to, I think it's time to spice it up a little bit.
Don't be shy. I came all the way from Zurich, so I'm happy to take your questions.
So regarding the last example, you mentioned the production of chocolate. For how much time did you run the sensor, so the whole apparature with the sensors, and if you had historic data, did you have problems with non-standardized data sets and stuff?
Yes, all of the above. Okay, so Lint is a relatively advanced company, a very good company, but still you go into a factory like this, the data, it's partly good and partly not so good. You need to do a data cleaning job at the beginning of a project like this, and that can be very large or not so large. Actually in Lint they have different factories, and some factories are more advanced than others. Of course, maybe they have newer machines, so you can read more. So that's to the last question. You need to do data cleaning. But once you figure that out, and you can provide the data in a standardized format, that job is done, right? Just make sure next time you implement, you can do it. Okay, how long do you have to train it? The thing is, when these guys produce 1 million balls a day on one line, and they have 14 lines globally, you don't need many days before you have a pretty good AI system. So we have access to historic data, and actually it's only using historic data. It's not the real time, it's more looking at the root cause. It can go on close to real time, but it's more looking at root cause and make sure eliminate it in the lean way, kind of. Is that, yeah?
You can just raise your hands, but in the meantime I have a follow-up or connecting question to this topic, because I'm not an engineer, I'm from a business school, purely business school, but I'm still interested. You mentioned sensors that collected data here, yeah, in the chocolate factory. So what kind of data? So how, again, I'm thinking chocolate sticks in those molds or something. How do you collect data on these kinds of events to identify the root cause you were? So what is the data? What are the 0 1s?
Oh, very good. Good question. If we think about, these are machines that make and do different steps in chocolate productions. Many of them are actually Swiss made as well, from company Bühler or from other places. So the machines themselves collect data. That can be things like voltage or pressure when you hit on the chocolate, or it can be speed, or or liquid flow. All of these things are sensors that modern machines come with today. Old machines don't have them. So if you have a combination, you struggle. And then there's things like temperature of the chocolate. That can actually be hard to, it's usually not integrated in a production system already. So sometimes you need to put on a sensor that can do it. Good news, you can buy very cheaply. It has to be industry grade, but then if you get it into the hole or something in a machine or a pipe, you can get the temperature. And if you want, you can get the temperature in many different spaces. Maybe it's important that the temperature kind of at the close to the pipe is coherent with the one in the middle of the pipe. All of these things are the difficulties in production, and with sensors you can add them. Let me say one more thing here. It's not about just putting on sensors. You need the right data, right? So then the question you have, engineering need to think, what data do we think we need in order to represent our system well? And engineers in chocolate production, they know. Yeah, it's viscosity, it's temperature, it's pressure, it's maybe outside temperature. And by that you can come down to a reasonable number of sensors, put them on a reasonable part of the production line, which provides you a good model. Never perfect model, but good model.
And then you combine this data with the yield. So to understand, okay, to go back to the root cause, or try to identify the root cause.
Excellent. So that's one more thing we need to know in addition to the sensor data. It's of course the batch number and timestamps. When does this batch number or identity of the chocolate go out? And then we need to just relate that to the yield on that day. And then we know basically everything. Then we can go in, and then what we also can do is to start to collect data about the raw materials. Now we still don't do, but we can do. Where is this raw material from? Aha! When it's from, when it's from Brazil, it tends to be a little bit different. Maybe the temperature needs to be it was sun drying differently. It's just AI system can figure these things out, and it's very hard for humans to come up with it just by thinking about it.
Okay. Any other questions, comments, please? You have also a microphone, if I think that helps, or could help.
You have mentioned...
Now it works.
I hear you, sir.
You have mentioned 4 different use cases, and they are really, really different from one another. And at the beginning, it was also mentioned that you have a startup, AI. So if you have been involved with a lot of different use cases, what is the product market fit of your startup?
So I've not been involved with all of these examples. So the question was about our startup Ethan AI and the different use cases. So let me first say, the Stanley Black & Decker case, the virtual reality, is a startup from California. We just use the technology. Most often that's what researchers do. We just use technologies to study something. The IKEA case is also, the drones are supplied by another startup, Verity, which is also a startup from a colleague of mine at DTH, the same person who made the Kiva robots in Amazon warehouses. The 2 other use cases, the Lint case and the Siemens case, are technology that we provide in the Ethan AI. So if you look at what do they have in common, quality. It's in the end all about yield, and the quality inspection is actually one of these points where you get that yield data, right? So that's what this startup focus on. AI for quality management has to be very, very specific focus, otherwise people don't get it, I think. Did that answer your question?
Yes, thank you.
Okay, next question.
Hello. You said that this AI. You said that this AI thing may be a good news or a bad news. What do you think the universal minimum wage that has been talked about?
Wow, that's a question for in the World Economic Forum events. That's the type of questions they discuss. And I'm gonna answer like this. That's not my area of expertise. I think, and that from my perspective, we only basically try to study how technologies can augment people at work, help them do a better job. If that leads to some people, losing their job because technology take their tasks, it's not really what we study. And if we get more productive, that's good for the world. That's my meaning. Now, if it's good for the world, then it becomes a question of distribution of wealth, right? And that's where the question of minimum wage come from as well. I don't know. Do anybody else in the audience want to comment on minimum wealth or wage in Romania, for example? So a very good question, very big question. I don't have the answer.
But do you think that this augmentation of humans could lead to bionic humans in a way?
Yes, if you like. I think so. Yeah, superhumans. You mean, or people augmented with technology? Yeah. Of course. In our study shows that I showed from the quality inspection task, the experts that use explainable AI outperforms experts without AI, and actually also outperforms AI alone. Now, the question is, do you want to use AI, or do you want to leave that to the others? And then I try to be technology optimist, right? And there's no simple answer. If you look at the experts, or the real experts on computer science and AI, they're divided. Are we close to general artificial intelligence and we're all going to be doomed? Or are we far away from general artificial intelligence and we're all going to do fine? The top experts in computer science are divided, 50-50. So you take your bet. I decide to go with the positive ones then.
In the front.
I have one more question regarding the chocolate production, because I'm studying in a similar field, chemical engineering, and it's a major part. So the question would be that, did the AI and the data sets show correlations to which the engineer said, yes, now we see some causes that maybe, are not just correlations, but are actually causes for loss of production?
Yeah, the short answer is yes. And then instead of then talking about the Lind case, there's this semiconductor case where we used the same technology in Hitachi. And they used this software to try to find what's the root causes are of loss in the semiconductor production. They tested it then in a field experiment. So some of the machines actually got the treatment that the AI system suggested and some didn't, and it did improve the yield in semiconductor quite significantly. So basically this system works, but at the same time there's still the engineer at the other end of the system that decides what to do. Yeah.
Thank you. I work for a thread company, Codes, and the big issue was how to forecast the next month or year production. My question is how the artificial intelligence could help forecasting the production.
Excellent question. So up to 2016, classic forecasting methods outperformed AI easily. Moving average type of exponential smoothing average outperform AI. Then there are some competitions for forecasting in which 2016 AI took over the race. But these competition use big data from Amazon, Uber, data that we don't really have in manufacturing. AI will improve forecasting methods. They will be implemented into ERP systems and forecasting softwares. But what I see in manufacturing right now is that you're better just as well off with a classic forecasting method. and combining the classic forecasting method. That's the, why do I say so? Because it has a huge advantage. You actually understand what you're forecasting. The problem with the most advanced neural network models is that they give you a forecast, but they don't explain you why. Then there's developments in AI, causal AI, explainable AI, that will help in that regard. But my short answer to you is you come very, very far with classic forecasting methods still. Good question. So if you keep an eye on that question, you'll find something that will improve at some point.
Hi. First of all, thank you for being here today. And my question is, how safe is AI? So we all know that humans make mistakes in production. And the examples you've shown regarding AI and digitalization is where humans use AI to improve what they're doing. Well, how safe is the environment where a human who can make mistakes interacts with something, an AI that doesn't make any mistakes? How do we prevent that? Or is it like an area of study which considers this risk?
Excellent question. Huge, very important. Lots of research in the moment into this, everything from ethical AI to trustworthy AI. These are words they use. I'm not an expert on computer science, so I cannot answer the technicalities of this. This is also maybe why in manufacturing, at least in our research, we always have a human in the loop, making the final call, try to help the human do this. Obviously, this will be implemented as well in companies that then say, well, if you inspect the product with AI, why do we need a human standing there? We just make a robotic arm. So if the AI said this is probably faulty, we just chuck it out, right? And then what happens if there's actually a faulty fire alarm system that goes to the market? That's what your question gets at as well. And it's super important to ask. And as you understand, not something that my group look at right now, but many, many others.
While you formulate your next question, I still have a question related to this humans and AI, but no, more broadly humans and digital technologies. You've shown us 4 very different use cases. I do agree with that, and I think also, can you a little bit walk us through how the role of humans changed in the different use cases? Because I think it's radically different as far as I see. Just think of the drones, where I would say it's almost completely replacing humans, while in the other one completely augmenting what humans do. And in this term also, my follow-up question would be, do you see any danger in this, or especially with the replacement of humans?
Wow, I wish I have another slide for this actually. Oh, lovely. So yes, you're right. Sometimes I draw a chart. It's automation, augmentation. Augmentation is helping humans do the task. Automation is removing humans from the task. You're right. IKEA's drones fall into the category of automating. In that case, I was, come on, the warehouse workers will not like this. They lose their job. In fact, here's how IKEA approached it. Nobody's going to lose their job because of the drones. Okay? Nobody. Instead, they're going to get better jobs. Because if you ask the workers, it was not so fun to climb on a ladder and count what's inside a box. Instead, they can go to the front of the warehouse and maybe even count open or broken pallets, as we say, when they are open, or help consumers and stuff like this. It's one approach to it, but that's IKEA case is quite dramatic. Most of the cases I show is augmentation. Actually, all of them, others are augmentation. Yeah, and I think it's a better approach. Why? If you augment people to help do their work better with new technologies, they may support your initiative next time because you make their life better. Maybe as the gentleman asked, I think he left, but if they get the part of the share, of course, the better salary or something as well in addition. I think it's a better approach. It's also the lean approach, actually, if some of you are interested in the lean thinking, because you want to have everybody contribute to transformation. You want to help people succeed in their jobs. It's much more fun to do an inspection job if you feel you succeed at it with a low cognitive load, then if you're there every 5th second, I take a bath, it's good. You get stressed about it, it's very stressful. So you want to lower the cognitive load. So I think the augmentation, as you used the word, it's a very, very smart place to start with digital transformation.
Yeah, there are more questions from the audience in that part.
Okay. So nowadays, AI is booming, it is really popular, and it is learning really fast.
No.
In this beautiful and interesting presentation, we saw 4 ways AI is interfering with production, but not in any kind of physical, material way. My question is, are there any examples of AI interfering with production nowadays physically? Are there any examples?
Oh yeah, there is. So I come from the management perspective of factories. It's a very good question, and I have many colleagues, for example, in mechanical engineering that study machines, machine behavior. So for example, one of the best use cases for AI in manufacturing is what we call optimal parameter setting. So it reads the part, it adjusts the machines, maybe it reads it while it's machining it, and it adjusts automatically based on an AI engine. That's the manufacturing process. At the far end, we also have material science, which I'm not an expert in, obviously, but they use AI to try to find the next materials. What are the materials that have the best kind of forming capabilities in a machine? Or what are the materials that are biodegenerable, so they can go out in the sea almost in the forest and actually degenerate without. So lots of AI over the whole aspect of manufacturing, also on physical products. Then in addition, you have the integration of AI in products. Think about cars. Cars, they say they even brake if you're driving too fast, new cars, right? And traffic light systems, self-driving cars, full of AI. So it's AI everywhere. And I only talked about managing factories and production and how it's seen in some settings there.
Okay, maybe there's time for one last short question. If someone has something, please. This is your last chance.
No, not the last. You can always send me an email.
Oh yeah.
Connect with me on LinkedIn. Yeah.
Last chance here tonight.
Well, I have actually a comment.
Okay.
Yes. I brought the gift to Levente. Yeah. He's a professor, and professors like to read. So I'm not taking this from your library. Actually, I brought it. This is 800 pages for Levente. So
thank you very much. Thank you, Torbjørn. Thanks a lot. I was actually looking forward to order this book, but you just saved a lot of time
and money.
So thank you very much, and some money, yes, as well.
It's a new textbook. It's the one up there. So of course, it's 800 pages. It took quite some time to write this thing, and I'm happy people read it, because otherwise that was a wasted effort.
Yes, I'm actually planning to introduce this because I'm also teaching operations management, among other topics. So I'm pretty sure it's a good source of inspiration, as it was, by the way, all of your examples and use cases today. So then, as just a very short closing remarks, again, thank you very much for being here and showing us these use cases. I think these are really meaningful and important experiences to learn from. And I hope that at your businesses or your future businesses or startups or whatever you are planning to do, you will also try to find those use cases that can really help you in a meaningful way and start walking this digital transformation road together. So Torbjørn, thank you very much for your presentation and for your thoughts. I encourage you to give a big round of applause to our invited speaker today. Thank you.